Technical knowledge often starts as a tangled mess. In this lesson, we'll turn that mess into a clear teaching sequence. Begin with the basics, build understanding step by step, expand carefully, and go deeper only when the learner is ready. You've built the inner foundation: confidence, presence, and control of your voice. Now we shift from sounding confident to helping technical ideas feel simple, organized, and easy to follow. Expert knowledge is not automatically teachable knowledge. When we explain technical topics, learners need a path. The foundation first, then the core concept, then an example, and only after that, the advanced details. Without that sequence, even accurate information can feel random and overwhelming. Structure protects the learner's attention. It helps you decide what to include now, what to save for later, and how each piece should connect to the next. A strong technical explanation does not begin with details. It begins with direction. First, define the idea in plain language. Then explain why it matters, the problem it solves, or the value it creates. Next, show how it works using the simplest mechanism you can. Finally, connect it to real use and point out common mistakes. This sequence keeps explanations clear, practical, and easy to follow. Before teaching details, give learners a simple handle for the idea. Start with one plain sentence they can repeat back. Avoid jargon, and don't define one unfamiliar concept with another unfamiliar concept. For example, an API is a way for two software systems to communicate. Once that basic meaning is clear, you can add terms, parts, and technical depth without losing beginners. With the basic meaning in place, learners need a reason to care. Tie the concept to a real pain point. With APIs, systems can share data automatically, integrate faster, and reuse services across products. Without APIs, teams rely on manual transfers, duplicated work, and fragile connections. That contrast turns an abstract definition into practical value: better efficiency, smoother experiences, and fewer errors. Next, move into how it works. Keep the path simple and sequential. Use action verbs so the system feels alive. The client sends a request, the API receives it, the server checks or processes it, and a response returns. Teach the normal path first. Save edge cases for later once the core logic is stable. Then make the concept feel useful in the real world. For an API, don't stop at systems talk to each other. Show where that happens. A checkout sends payment details to a gateway, a mobile app pulls product data, or a cloud workflow triggers automation. These examples help learners connect the idea to tasks they may actually perform. Strong explanations also protect learners from predictable mistakes. Instead of only saying, "This is wrong," name the mistake, explain why someone might make it, and show the corrected habit. For example, a beginner may assume every API is public because examples often use open endpoints. The correction is to clarify that many APIs are private, internal, or protected. This turns confusion into a best practice learners can apply. Layering is how you prevent cognitive overload. Start with the simplest meaning, what the idea is and why it matters. Then add architecture, workflow, examples, edge cases, and only later implementation detail. Each layer gives the learner a stable place to stand before the next one appears. It also lets you adjust depth. Beginners may need meaning and examples. Advanced learners may be ready for exceptions and code-level decisions. The first layer should make the concept feel simple. Use a plain definition and, when helpful, a familiar analogy. Then give learners the architecture, the main parts, and how they relate. For cloud storage, that means the user or app, the storage service, access control, and the files being stored. Keep this view high level. Do not add settings, policies, or code yet. You are building the mental map learners will use later. Once the parts are clear, show how they work together in a normal sequence. Start with the happy path. A user uploads a file, the system validates it, storage saves it, and a shareable link is created. Then anchor that flow in a realistic workplace moment, like uploading a profile image or project document. The workflow gives structure. The example makes it easier to remember and apply. Advanced detail is valuable, but timing matters. First, teach the normal path until learners can predict what should happen. Then introduce edge cases, oversized files, missing permissions, network failures, retries, or security limits. After that, add implementation details like configuration, commands, validation checks, and error handling. The goal is not to hide complexity. It is to sequence it so beginners build confidence before they handle exceptions and tool-specific mechanics. Knowledge dumping usually comes from good intentions. We want to be complete, but beginners need a filter. Start with must know, the facts they need to follow the concept right now. Add should know only when it improves understanding without slowing momentum. Save advanced details for practice, documentation, or questions. This keeps the lesson clear, protects working memory, and gives learners confidence before you add complexity. You now have a practical method for clear technical explanations. Start with what, why, how, where, and mistakes. Build in layers from basics to implementation. Then filter details so learners get what they need when they need it. Next, we'll turn this structure into stronger technical storytelling.